So, hi everyone, this is the PCD for Codeforces round 906. And the first problem of this contest, Doremi's Paint 3. The problem says that we would be given an array of size n and we can permute this in any way. So, yeah, the problem is that we would be given an array b of length n. There can be any elements here, and then we can permute it. So just any permutation of this array B, let's say the new permutation is B dash, and we have to tell if it is possible to form a B dash where for every two adjacent elements, the sum of every two adjacent elements is same. The sum of these two elements is equal to the sum of these two elements is equal to the sum of these two elements, which is equal to the sum of these two, and these two, and so on. We have to find this. Just please confirm if the problem is clear or not. We just have to return yes or no, whether it is possible or not. Okay, so what we can do is just try to think that you have to make the sum of two adjacent elements equal. Can I say that if I have the sum of the, first of all, the array which I have been given, whatever array B I have been given, the order in which the elements come doesn't matter. If you notice, the array 1, 2, 3, or if you are being given the array 2, 1, 3 or something like that, it doesn't matter what is the sequence of the numbers as long as the elements which are coming are same. So in such problems, it is always good to just consider if the array is sorted. It generally helps us to think either sorted or just frequency wise. Though it's not gonna create a very huge difference here, but what we can do now, like if you just try to think of the array is sorted, because the answer for this input would also be the same. You know, right now we have been just thinking, what if it was sorted? You can observe one thing, that if I have the sum of two elements, let's say if I have 1 and 2 coming together, the smallest two elements coming together. So whatever their sum is, for any two elements in the array other than them, the sum would either be greater or would be equal in case if there is like what uh, like this. है ना? But there is a chance that the other two elements might have a larger sum. If it was something like 1, 2, 3, and you pick up 1 and 2 together, then for 2 and 3, the sum can be larger. And when you think about it, you will come across something, a pattern like this. The smallest value, then the largest value, then the smallest value. If there were n values and the elements are a0, a1, a2, and so on till a of n minus 1, then you can think about placing them something like this: a0, a of n minus 1, a1, a of n minus 2, and so on. Right? Just please tell me if something like this is coming to your mind or not. At least you are able to think if we try to think about it in a sorted way, you can observe this thing. If you are having the smallest and the largest element together, then the largest and the second smallest element, then the second smallest, second largest, then there is a chance that they might have equal sum. But if you were having something like any two small elements together, then the sum of two large elements, if they come together, it would be greater. Please confirm it once if it is clear or vague. Okay. I don't know why only one guy is replying, all the others are not even saying yes, no. Okay, so that's good. Now you like this is pretty standard. Whenever you come across something like that, when you want to have minimum absolute difference between, or sorry, maximum absolute difference between two adjacent elements, or want to have the sum of two adjacent elements as close as possible, something like that, you should try to think about this kind of pattern: the smallest value, largest value, second smallest, second largest, and so on. And another pattern is the largest value coming first, then the smallest, then the second largest, then the second smallest, and so on. है ना? There can be these two kind of patterns where you have largest and smallest values coming one by one alternatively. And now you can just check up for these two arrays. If one of these arrays is having the sum equal for all adjacent elements, then the answer is yes. Otherwise, the answer is no. So let's look at the code. It was a constructive algorithm problem. Here you just had to find this kind of pattern. Generally in constructive algorithm problems, you just look for patterns. It is better instead of trying to logically go everywhere. Now we can just in the input, what I have done is first of all taking up the inputs in the code. I have first of all taken up the inputs, then sorted the array because sorting will just make the things easier or doesn't do anything, but it will never make things hard for me. Next, I created an array in which I just did put up stuff like the way in this pattern, as I discussed here. Now, since as I said that this is something a little standard, you can uh, just try it yourself first. And if you're not able to do it, then you can look up my code and you would be able to do it. It is not very hard. And I created a function in which I would just pass on that vector and it would return me if that vector is valid or not. If the vector is valid, then just print yes, otherwise no. And that's it. So please confirm if the problem is clear or does anybody have any doubt? If you have any doubts, then please write it inside the chat. Okay, so map can make it easier. Maybe map might be better thing here. During contest, this came to my mind. I did like this. Okay, so let me repeat it once. What I did is that first of all, I took the inputs, then I sorted the array because I wanted to create such pattern. So one way of creating such pattern from a sorted array is that just print up the, like, you just sort the array, you have the array like this. Then once you sort the array, you will have the pattern like this, array like this. Then you will first of all choose the smallest element, then largest, then second smallest, then second largest, and so on. So you will just have low and high pointers, and you will keep placing one and incrementing or decrementing low and high on the basis of which element it is. In that way, I created the array B for both of the ways. First of all, starting on with A0 at the first place, and in the other array, I just took A of n minus 1 at the first place. And after creating the array, both of the times after creating the array, I just passed it on inside the check function, which will return me true or false. Yes, this is the problem A. So should we move on to the next problem? Okay, great. Yeah, let's move on to the next problem then. So this is problem B. In the problem B, it says that we would be given a string S, and we say that a string S is good if all the adjacent elements are different, and the string is having only 0 and 1s. So it means that one of the elements would be 0 and the next one would be 1, or 1 0, something like that. If you ever find 0 0 or 1 1, in that case the string is not good. And what we can do to make it good is just insert a string S. Like in the string S, we can insert a string T at any position we want, and we have to tell if it is possible to make the string S good after any number of operations. So let's see it here. You would be given a string S, any string S, which would have 0 1 0 1, something like that, and it can have adjacent elements equal as well. If the adjacent elements are equal, we don't call it good. we call it good only if all the elements, all the adjacent elements are different. All the elements are different from its adjacent elements. And what we can do is insert a string t anywhere inside the string s, and we can insert it multiple times as well. And our job is that to tell if we can make string s good. We have to tell this part. So is the problem clear? That we are being given a string s and t, we have to tell if we can make string s good or not. And what we can do in one operation is just uh, choose any index, any place where we would insert the string t, and our string s would be modified. After that, we can just keep repeating it as long as we want. And we have to tell if it is possible or not. Let's look at uh, some special cases. What if string s is already having alternative elements? In that case, it is already good. And you can think about these cases, though it won't really help us here. The case you would come across which would help us is that, first of all, in string s, we will never apply any operation if the adjacent elements are already not equal to each other, because it is not going to help us in any way. It would help us only if there are two adjacent elements which are equal. Only then it makes sense to apply an operation and insert the string t between this place, right? Please tell me this point, that did you notice this, that only when you have two consecutive elements equal to each other, only then it makes sense to insert the string t between it. Otherwise, it never makes sense if the two consecutive elements are not equal. This was the first observation you could make. Secondly, if the string t is having one, like it is starting from 0 and ending at 1, or if it is starting from 1 or ending at 0, in that case, it never makes sense to use the string t for inserting at any place, because the both the elements at uh, both the elements where you insert t, between which where you insert t, would already be equal. Only then you would be inserting t. So if both ends of t are not equal, in that case, whenever you insert t, one of the ends will definitely match with one of the endpoints. So in that case, inserting t will never help you. And next point, which even Sahil pointed out here, is that string t must be good in itself. If string t is not good, in that case, again, it doesn't make any sense to insert string t because it is not good in itself. So it will just make your string s bad. है ना? So the second observation is that why, just identify. In the first point, what we did was to identify where would we insert t if we insert. है ना? Secondly, we observed that should we even insert t or not? Does it even make sense to insert t or not? So it doesn't make sense to insert t if both the endpoints are different from each other, or if string t is not good in itself. है ना? In those cases, we would not insert string t anywhere. Please confirm it once if you are able to understand these 2 points. Okay, great. Now everything is simple. We can just iterate over the string s, whatever the string s is. We can just iterate over it. Whenever we find ones, okay, there was one more observation. If we are inserting t here, yeah, if string t is bad, then it doesn't make any sense to insert it. But if string s is already good, in that case, it is still possible. So if string t is bad, you cannot say ki you will never be able to find it. Okay, now the third observation is that if you are inserting t between two ones, then the endpoints of t must be 0. Otherwise, it is still gonna keep the string bad. है ना? If you are having the endpoints as 0, only then it would be making the new string good, right? So first thing was that you will insert t only if there are two consecutive elements which are equal. Secondly, you will insert t only if string T is good in itself and have two elements which are equal. And the third thing is that the endpoints of T, let's say they are 0, 0. In that case, you can insert it here. Otherwise, if they were something like 1, 0, 1, 0, 1, if the endpoints were 1, in that case, you cannot insert it here. Because if you insert something like, let's say 1, 0, 1 between 1, 1, then it would still have some adjacent elements which are equal to each other. So please confirm this once that are these 3 points clear? That's all in the problem. The problem is only this much. You can just iterate over the array, iterate over the string, and whenever you find two adjacent elements, just check that if they are not equal to string T, and before checking that, like one way of approaching this now can be to just check if string T is good or bad. If it is bad, then just mark it somewhere. I just created a bool okay, which I initialized with true. If I see that it is bad, then I said that okay is false now. If the endpoints of T were not same, if T0 and T of m minus 1 not same, then again this T will become false. And in case like after that, if both of these things are good, if T is good and both of the ends are same, then I will say that there is something like uh, not even this is required. You can just iterate over the string S, and at any place whenever you find that two elements are equal, just check what is that element. Let's say if that element is Si, it should not be equal to T0. If it is equal to T0, in that case you would say that it is never possible. The string is bad. Otherwise, you will just ignore this because you can insert T here and everything would be good. Uh, so, okay, so everyone got it. Let's see the code then. That's what I did here. As I explained here, everything is same. First of all, took inputs. Then I declared a variable okay with true. I checked if string T is bad. If at any point I see that string T is bad, then I will say okay is false. If the endpoints of string are not equal, in that case also I will say okay is false. This okay is just telling if I can insert T somewhere or not. And then this thing is not required. You don't really need to keep this thing in a variable. You can even use it directly. But I just stored it in a variable h, and at any place in the string s, if I find that two elements are equal and uh, it either I can't insert t or the elements are equal, in that case also I cannot insert t here, then in that case I would say that the answer is no, because I cannot insert t and make the string good. And in case if it never gets returned anywhere, then it would print yes. So is this clear? Okay, great. So let's move on to the next problem then. This is quite weird name. So the problem is a little different now. The idea behind the problem is same, that you would be given a string. This time you would be given just one string of 0, 1, like either 0 or 1, containing zeros and ones. And now in one operation, what you can do is that you can insert a 0, 1 at any place. Instead of t, now it is fixed that you can insert 0, 1, a string 0, 1 anywhere. You can apply at most 300 operations. You can apply at most 300 operations, such operations. Here n is less than equal to 100. And now here in this problem, we say that string s is good if it is not a palindrome. So string s is good if it is not a palindrome. In the problem statement, they didn't clearly say this thing, but the equation they have given that uh, in the string, first element should not be equal to last, the second should not be equal to second last, and so on. Okay, so sorry. It's not really about palindrome. It's even stricter than that. That even if any two elements, any two mirror elements are equal, let's say these two are equal, then the string would not be good. Like that. The expression is Si should not be equal to S of n minus uh, I plus 1, where we are using one based indexing. This is the expression. So it would be true for all the I. Is the problem clear? Yes, no, something. Is the problem clear? We are being given a string, a binary string having either 0 or 1, and the length would not be too huge. We can apply at most 300 operations. In one operation, what we can do is insert 0, 1 at any place. And our motive is to make the string S such that for any element, the for the first element, the last element, like if you talk about the first element from the start, then it should not be equal to the last element from the start. If you talk about second element, it should not be equal to last second element. Third should not be equal to last third, and so on. This is what this relation says. So in this problem, you could have tried to, first of all, notice this thing that n is not too huge. Maybe we can use this thing somewhere. And nextly, if there is something like uh, zeros coming, let's say 7 times, and one is coming 3 times in any string, then it will never be possible to have this relation. Because if you take that this is your string, and this line is just dividing the string into two parts, two equal parts. So what you want is that whatever the string you have here, let's say 0011, on the other part you should have it flipped. You should have it flipped and in the reverse order. So for 1 it would become 0, for the 1 it would become 0, for 0 it would become 1, and for 0 it would become 1. Now it explicitly means that if a string is good, the number of zeros and ones should be equal. The count of 0 should be equal to the count of 1. This is the first observation. Is it clear? No, if the count differs by 1, even in that case, it would fail. It will fail even in that case. Because you see that if there is something like 010, this character is gonna be compared to itself. And like if n is odd, then the answer is always not possible. And if n is even, in that case, you will have them equal or not equal. है ना? So one of the observations is this thing also, that if n is odd, in that case, the answer is definitely no. And as the output, we don't have to say yes, no this time, but this time we have to say, we have to tell at what places will we apply those operations. We have to tell that thing as well, the places where we would apply the operations. So one thing which was clear to me was the first element should not be equal to the last element, and then we will talk about everything inside. है ना? So for that, what I did was just observe that, let's say if this guy and this guy are not equal, and I apply any operation in this remaining substring, whatever happens, these two elements will still remain different, right? If a0 is not equal to a of n minus 1, or let's say string s here, so if s of 0 is not equal to s of n minus 1, which is the last element, and I insert some string in between, the first and last element would still remain different. They will still remain different. So it means that whatever operations I apply here, it is independent of outside world, which gives us the intuition that you can start comparing the last corner elements. Then once they are being settled, then consider this substring. Once these elements are settled, then you can consider the inner substring, and so on, until you are left up with empty substring or just two elements. If the size of the answer should be less than equal to 300. Yeah, you can say this thing also that uh, basically you will have answer greater than 300 only if this is not satisfied. So this observation is better. The next observation is considering outmost elements is better. Like considering or maybe comparing the corner elements for any string, just comparing the outside elements and then considering the inside string is better. So you can say that you will be having a string, you will just consider the outmost elements. After that, once they are equal, now the remaining substring you have, this one is gonna be independent of whatever you had initially. And now the thing is, let's say if in your substring the corner elements are 0 1 or 1 0, basically they are different. You don't need to do anything. You can just say that they are different. Now I would consider this substring because whatever you do here is not gonna affect the outside elements. So it is just better to consider this substring separately. So this is the third thing. If the outside elements are equal, then, or basically if the elements at low and high are equal, then say low minus low plus plus and high minus minus, you don't need to worry about it anymore. The fourth thing, what if the outside elements are same? Let's say if they are 1 1 0 0. Now, what do I need to do? What should I do? Just try to think about it. They are not good by themselves. So I need to apply an operation. Now in an operation, I can insert 0 1. Where should I insert it? If I insert the 0 1 in this range, anywhere inside this range, it would not really affect these two because we saw it earlier that the elements at the corner are not going to be affected by whatever we do inside it, inside between them. So we either insert the element, insert 0 1 at the start or at the end. If I insert it at the start, then the first element would now be 0 and it was already 0 and it would again be equal to 0. So applying this operation is redundant. It's not really helping me out, which gives me only one choice that but if I try to insert 0 1 at the last, now you see that your string, like whatever you had here, would still be here and you will have 0 0 1 now, like this. Now these two are different and you can consider only this part. And this part would also have the count of 0 and 1 would still be same. The count of 0 and 1 is still same. है Now we have just reduced the sub. We have just reduced our problem and got to a sub problem. And after like if the size of the string was n, then we reduced it to n minus 2 in just one operation. We used only one operation to reduce it, which helps us to understand that either we don't apply any operation or we apply an operation. So we would require at most n by 2 operations, which is not problematic for us. Now you just need to make sure that you keep track of the elements you have added. And here comes that n is less than 100 part for a rescue. If you see that n is very small, so even if you just apply that brute force, that whatever string you had, and you insert 0 1 explicitly by using the function str.insert the index and 0 1, it will do the job in big of n, which is fine here because we can have n square time complexity per test case, and even then the code will be pretty fast. So now our problem is pretty simple. We just have to keep track of low and high. If the elements at low and high are not equal, then low plus plus, high minus minus, Otherwise, if they are equal, in that case, just see if both of them are zeros or ones. If both of them are zeros, then it makes sense to insert 0, 1 at the end only. If the both of them are ones, then it makes sense to insert 0, 1 at the start. Now, one thing you need to observe is that initially you had low here and end here. Sorry, high here. But now your high should not point to this place, but instead it should point to this place. Zeros remain the same. The number of zero ones remain the same. Are you asking for this part? Please tell me, are you asking for this part? Okay. So you see that whatever the count of 0 and 1 was initially, the count of 0 and 1 was already equal. If it was not equal, then you would have not been considering this, right? You would have directly said that it is not possible. You inserted 0 and 1, you inserted this 0, 1, so the count incremented by 1, and you cut this out 0 and 1, so the extra got cut out and the count is still same. I hope this doubt is clear. Let's come back then. So here we were at this point that we can just have low and high pointers at the, like we are just having 2 pointers approach here at the edges of the string. Then we see that if the elements, these are not two zeros, these are two elements basically, any two elements. If they are not equal, in that case, just low plus plus, high minus minus. If they are equal, then there can be two cases, either both of them are zeros or both of them are ones. So if you see that you are having uh, low and high, and you insert 0, 1. So your high was initially at this place. Let's say if in this, we are talking about this case. Now your high should actually point to this place. So when we insert the string, we will just say that high plus equal to 2 also. In case, and yeah, we would be inserting the string at this place. Our high is this, and we want to insert at this place. So we would just push back high plus 1 into our answer. We would just have uh, the operation at this index. In case both of the elements were 1, then we would have been inserting 0, 1 at this place at which low is pointing. So we would insert low into our answer, and high would again be incremented by 2 because two elements have been added to our string. And this was all the casework we required for this problem, and I've discussed it. I've actually discussed the complete intuition. So I hope that this C problem is clear. Just please confirm, just please tell me once yes, no in the chat that whether the approach is clear or not. Okay, great. So let's look at the code now. This is in queue. Okay, it got accepted. So what I've done here is that first of all, I took the input, the string, and then I calculated the count of zeros and ones. If the count is not equal, in that case, just directly say -1, because we had to say -1 if we cannot make the string work. If it is not one, if they are equal, in that case, we can always make it equal at some point with at most n by 2 operations as we discussed there. And we could actually use 3 into n operations. So we then don't have any problem there. Then we are having these two pointers at 0 and n minus 1. And while they are while low is less than equal to high, if the elements are not equal, in that case, low plus plus and high minus minus, because we don't need to do anything here. If the elements are equal, only then it would be coming till this point. So we are just checking if the first element, both of the elements are equal. So if they are equal to 0 or 1, if they are equal to 0, in that case, we would be inserting element at the end as we discussed. So in the answer vector, we will just push back high plus 1, and in the string, we will insert 0, 1 at the index high plus 1, and high will be incremented by 2. In the other case, when we had uh, both ones, in that case, we were inserting low 0, 1 at the index low, and answer can, in the answer, we are just pushing back low, and high is going to be incremented by 2. Then at the end, we just print out the answer we have. So just printing out that. answer dot size and all the elements in the answer array. So is it clear? Okay, great. Let's move on to the next problem then. This is the D problem of today's contest. The problem says that Dorami lives in a country consisting of n cities from 1 to n. AI people are living in the ith city. It is modeled as undirected graph with n nodes. Initially, there are no edges in the graph, and for adding an edge between cities I and j, what we need to do, like the condition which must be satisfied first, is that the sum of the uh, cities in both the let me use one note here. So what it says is that there are n cities, and in the ith city there are ai number of people. In the ith city there are ai number of people living there, and the cities can be visualized as some nodes of a graph, nodes of a graph of an undirected graph. Currently there are no edges in the graph. If we want to insert an edge between any two nodes I and j, I and j are the city numbers since the cities are from 1 to n. So what we require is, there will be some constant c also being given to us. What we require is the sum of all the numbers, the sum of, or maybe you can say that the number of all people who are living in the component, uh, the same component as of I, and the number of people living in the component of j, which can be calculated as ak summation of ak, where this k would belong to s, and this s is the uh, set of cities of or which belong to either the component of I or j. Uh, right now, it might not look very clear, but in the next connection, it would look clear. So right now, when you want to insert them, there is something like this expression, which should be greater than equal to I into j into c, where I and j are the city number and c is a constant. So let's say that I wanna combine this city and this city. I wanna insert an edge here. So this term will be the summation of the number of people living in this component and the number of people living in this component. That's what this expression says. And if that expression is greater than equal to I into j into c, in that case we can say that it is possible to insert an edge there. Let's say if it is some k. Let's say if there is some city L and some city M, which are being connected already. And now I want to insert an edge between J and L. So it means that like the condition there will be that the number of people living in this component and the number of people living in this component, the summation of that should be greater than or equal to I into j into c, where these I and j would be actually j and l if I wanna insert an edge here. So please confirm me once if this is clear or not. In case if you have any doubt regarding the question, then please ask me. The answer we have to print at the end is something like yes or no, telling if we can connect all the nodes in the graph or not. There are 7 people in the meet and only one guy has been replying. What about the other 6 people? Is it mandatory to have connected graph means one graph? Yeah, देखो, at the end, initially all the nodes were disconnected from each other. Now what we want to do is insert edges between nodes. And while adding edges between nodes, there is a condition that the all the cities which are directly or indirectly connected with these two cities, or basically they are in the same component, should the sum of all those cities should be greater than or equal to I into j into c. Or you can visualize it in this way, that if you insert an edge here, between any two cities, then all the cities which would be in the same component, we are going to be talking about the summation of them. And we have to compare it with this thing. So is the problem clear now?
Yes.
Okay, great. So what we can do, like what came to my mind after this was that either I increase, like either I try to maximize this part, maximize this, or minimize it, minimize the part on the RHS, because I wanna make that condition true, as I want to connect all the edges, all the nodes. So for that, I decided one thing, that if I wanna connect 1 with 3 and then 2 with 3, instead of that, since I have to connect all the nodes at some point, I decided that I would connect all of them by one only. 1 with 3, 1 with 2, 1 with 4, and so on. So that I would be minimized. I would be equal to 1. So the RHS will become just equal to J into C. This C is a constant, so I cannot really do anything about it. And for this J, one thing you can notice here is that it would be easier to connect 1 with 2 than connecting 1 with 3. Like easy, the cost will be increased when I want to connect 1 with 3, and the cost will be increased when I want to connect 1 with 4, and so on. Which means that in any case, if I see that I can connect 1 and 4, then I can connect all these together. Like after connecting 1 and 4, I can connect these also, because the component would have become quite large, and uh, I would have the LHS large enough to connect with these as well. Is this part clear? Is this part clear? This is an important observation here.
Yes.
The observation is, okay, let me repeat it. This observation is very critical, very important, that if you can connect 1 with 4, which means that uh, whatever was the like whatever be the component you have after connecting 1 and 4 is having the summation of AK, the summation of AK is greater than 4 into C, right? It means this part, if you are able to connect 1 and 4, right? Just please confirm this part. If you are able to connect 1 and 4 together, it means that the summation of all the nodes which are connected or directly or indirectly connected with 1 or 4 is greater than 4 into C. It doesn't matter if the number of people in city 1 is less or greater. What you care about is that here is the city 1, here is the city 7, or let's say city 4. So you don't really care about the number of people here or here. You just care about the sum of the number of people in the cities who are directly or indirectly connected with the city 1 or 4. So if that count is greater than 4 into C, now it means that after adding this edge, all these people are directly or indirectly connected to 1 also. And even the people who were connected with 4 now are connected with 1 as well, directly or indirectly. So it means that the new summation I would have will definitely be greater than this 3 into C and 2 into C as well. Yeah, I can connect it. If I can connect 1 with 4, after that, I would have got such a large component which is sufficiently large enough to connect 1 and 3 and 1 and 2 as well. Which means that I will be having 1, 2, 3, 4 connected with each other. After that, I will try to connect 1 with 5. I'm already having this component. Let's say I was not able to connect it. I was not able to connect 1 with 6, let's say. Then when I talked about 1 and 7, 7 was having a lot of people with it. So I was able to connect it, let's say. Just assume if I was able to connect it. Now I have got this component 1 with 2, like 1, 2, 3, 4, and 7 are being connected with each other, are now in the same part of the of one component. So this component is having the total number of people this component has is greater than equal to 7c, which means that it is gonna be greater than equal to 5c and greater than 6c also. So I can connect with these also, even if these cities had zero number of people, even in that case, I would be able to connect them. And when I connect them, I can just say ki whatever number of people you had, just please tell me so that I can store it that I have got this large component. And
मतलब बाइनरी सर्च जैसा.
not binary search. I can do it directly. Like linear, big of n is minimum, and I can do it with big of n directly. So now what approach I've got to know, which looks working, is that I can think I will have node 1 at the beginning. Then I will say that can I connect node 1 and 2? I will just check if I can connect node 1 and 2 together. Whatever be the result. If I can connect, then I will connect them and tell that the number of like I will just have some variable, let's say people, in which I will store the total count of the number of people I have in this component. It will tell me the number of people I have in this component. That's how I connected them. Now when I will talk about connecting it with 3. The reason I tried to connect 1 and 2 before 1 and 3 was because 1 and 2 was having a lower cost for connection as compared to 1 and 3. Now, if I can connect 1 and 3 also, then I will uh, increment the number of people here so that I have the track of the number of people I have in this component. If I'm not able to connect them, then I will look for connecting it with 4, 1 and 2 with 4. Let's say I'm not able to connect them as well, then I will look up for connecting them with 5. In case if 5 is having a lot of people and I'm able to connect them, now I will have sufficiently large enough number of people in this component, which is enough to connect 1 and 3 and 1 and 4 also. So I will connect these people as well and will keep doing it till I reach the node n. At the end, when I reach the last node, if there is you can say that if I'm not able to connect to the last node, it means that I cannot. Um, you can just say that I will just try to connect all the nodes till n. And at the end, if there is any node which I could not connect in my graph, if at least n would be there if there is any node. But even if you don't look at that part, you just say that if there is any node which is not connected to one, the answer is no. Otherwise, the answer is yes. Right. Right. That if there is any node which is not connected to one, in that case, the answer is no. And for keeping track of the nodes which have not been added to, which have not been connected to one, you can just maintain something like a set or a vector or a queue, like any data structure in which you just keep track of the number of nodes you have not the node, uh, basically the nodes which you have not connected. If you try to even optimize this, you would be able to store this it inside just one integer as well, but you don't really need to go in that much optimization. A set is fine. Okay, so let's look at the code then. This was a greedy problem. We went with greedy solution here. First of all, I took the inputs, uh, taking up the inputs here, and while taking inputs, uh, I just kept track of the number of people who are directly or indirectly connected with the node 1 in A1. Instead of creating a new variable, I just kept it in A1. If till k node is possible, then it is sure that all the node less than k is also possible. Yeah. If you can connect till node k, then it is possible. It is definitely possible to connect with all the nodes less than k, because here the cost will only reduce. The cost is only going to reduce. And when you connect with k, you have already got the submission too large for connecting with all the other nodes. है ना? Because the thing is, when you connect two nodes, what you want is that after connecting them, the total number of people in the component should be greater than this k into c. So if you are connecting like 1, 2, and 5, you have already got this component having people greater than equal to 5c, which means that this component is itself sufficiently large to connect like this one and this one. How to get indirectly connected? Uh, I didn't understand this part. What do you want to ask? And by the way, we are going to be directly connecting one and every node in our solution, because connecting any node like with one and some node is always better. If you have a component 1 and 2 having two nodes connected with each other, 1 and 2, and you want to connect this component with node 3, so having this is not good. Instead of that, having this is good. Connect, because connecting nodes 1 and 3 would have 1 into 3 into c cost, whereas if you try to connect 2 and 3, it would have the cost 2 into 3 into c, which is comparatively more. So it's better to try to connect them like this. And the sum of the people in this component would definitely be the same. So what you can do is just say ki, except the first node, like when you're talking about any other node except the first one, you can just say that if the number of people you have in the first node, if the in the component of the first node and in the ith node is greater than equal to c into j, which means that you can connect them. So here what I'm doing, one more thing. Here what I'm doing is, let's say there is a component like this. What I'm doing is storing the count of the total number of people in the whole component in a variable 1j, 1I, a1, in just one variable, so that I don't have to find the total number of people like the summation again and again. This is just a minor optimization. Yeah, they are not connected with you. Initially, all the nodes are uh, disconnected from each other. And for the part of when I connect one with two, and now let's say I could not connect it with three and with four. Now when I connected it with five, so I have to find out how many people were there and how many people were here, and increment it to a1. For that, I just kept a variable pending, in which I just added the number of people who are pending, and once they are being connected, then say this pending equal to 0. So here this set was actually not required, just integer was enough, but no problem. I inserted the new node into pending, and after that I checked if I can connect them. If I can connect them, then it connect them, connect all the edges less than equal to that node, and clear the pending nodes. At the end, if I have any pending node, in that case, my answer is no, otherwise it is yes. You can have a different way of implementation as per your style of coding. We can also use prefix sum whenever. Okay. Yeah, you can use prefix sum, but prefix sum will just take up big of an extra space, which is not really required. Yeah, just using a variable is enough. This pending variable is enough. So please confirm if the problem is clear or not. Should we move on to the next problem? Okay, great. Let's look at the last problem. Like today, we would be discussing till here only. So in the even problem, what it says is that there are n cities, and m days. For every day, we are being given that from city Li to like for the ith day, there would be rain in the range from Li to Ri. All the cities in this range. The cities are from 1 to n, and from Li to Ri would have range. So let's say if the Li is 5 and Ri is 7, it means that on the ith day, there would be rain on the cities 5, 6, and 7. This is the problem. Like this is what this array is telling us, and what we can do is avoid rain or prevent rain for any of the 2 days, any 2 days of our choice. So let's take an example. Let's take this example 232. By the way, there is this k as well for not 2, but for any k days, k number of times. But in the easy problem, k would always be equal to 2 in the easy version, which is even. So let's take if the number of cities are 2, the number of days when it would rain is 3, and on the first day, there would be rain in the city. Let me just confirm it once. Yeah, 1, 2. On day 2, there would be rain in cities 1, 2. And on day 3, the city 1 and 1 will have rain. So only city 1. What we can do in this case is avoid this rain and this rain. So only this rain will happen, and it will happen on the city 1. So city 2 will be dry. City 2 will be dry. Here in the problem, we have been told that if there is any city on which no rain happens for the next m days, for these m days, then it is being considered as dry, and we have to output max number of cities uh, which can be dry. Uh, our motive is to find the maximum number of cities which we can have dry if we choose these 2 days optimally. So for the problem, what I did was to take it like this. I took the problem as if I am being given an array from 1 to n, the indices are from 1 to n, and there are m queries. On the mth query, like on the ith query, you will be given one subsegment, one subarray, on which you will just go and increment everything by 1. Except, yeah, and what you can do is out of these m queries, you can ignore 2 queries. You can ignore 2 queries and want to maximize. Initially, everything was 0. Initially, everything was 0. In every query, it was being incremented by 1. And at the end, what you want is maximum aj such that they are 0. Maximum elements in the array which are 0. So that's what you want to have. In the other way, what I did was to just say that for all the cities which never come in any of the subsegment would always remain dry, you know, which never come in any of these subsegments will definitely be dry, right? Yes, no, something like yes or no. If there is any city in which rain never happens, so even if I don't do anything for this, they will definitely be dry. I can just find that count and increment it to my answer for sure initially. For all the cities which are being rained by only one rain, if these are the cities I have and this is the range in which rain is happening, on one of the days. If I prevent this rain, then uh, these will have one less rain. If only once the rain was happening in these cities, then it can be prevented, right? So let's say that ith city, or before that even let's have a different perspective. This is rains I, or maybe some other name. Let's say days I, where this will take, which will tell that days I will tell how many days rain happen here. Rain happen here. On how many days rain happen here. So if there is a let's say the rain on second day is happening here, and in this range, uh, rain is happening on third day. So this subsegment will have two, stored that two times rain will happen here. Uh, yeah, it is storing how many times rain will happen. No. It is not telling how many times rain will happen on that day. It is telling how many times. Uh, Maybe I said it wrong. Yeah, it is telling how many times rain will happen on that city. For let's say I, it will tell you that on city I, for the ith city, how many times rain is happening. For the ith city, how many times rain will happen, or how many different days it will happen. It will just store this thing. Now I can say, let's say we have rains I as an array, which will tell that how many cities are there, how many cities are there which are being um, made wet or rained by this by the ith day. Here this I is telling about the ith day. So on the ith day, how many cities are there which are gonna be made wet only because of this day? So if I prevent it, let's say that these cities are will remain dry if this second day was not rained. If I could avoid rain on the second day, then these cities will not will be dry actually. So if I avoid rain, let's say that these are all cities on which rain happens only on one day. So if I avoid that day, if I avoid rain on that day, then these will remain dry, right? So what I'm willing to find is what I'm willing to find is for every day, how many cities will remain dry? How many cities will remain dry if I avoid rain on this day? Avoid rain on this day. Now, uh, for the people who have been coming up to upsolve the even problem, I expect that it should not be hard for you. You should easily be able to just sort the all the segments you have been given, all the subsegments you have been given, and for every day, one by one, you just go on for every day and keep track of how many cities will there, how many days will there be on which you have rain for this, for the current city. Here we are just iterating over the cities, and for the ith city, how many days will be there when it rains. And in case if there are only, let's say if the count of the days when it would rain is only 0, then you can increment the answer. If the count is 1, then you can just find out which day it is, and for that day you can just say rains of that day should be incremented, that if you avoid rain on this day, then one more city would remain dry. And you can find, if the count is 2, in that case there will be 2 days, है ना? Day 1 and day 2, day 1 and day 2. So you can say that a combination of these day 1 and day 2 has rain. You can store it somewhere, maybe in a map. Now this part should not be hard for you if you are actually up solving till even. You should be able to solve this part on your own. I will show my code for reference, but I'm not really explaining the whole implementation of how we do this. And in case if the count is equal to 3 or greater than equal to 3, in that case, whatever you do, this city will not be dry. You cannot have the city as dry. Now, here we are talking about the ith city. We will start from the city 1 to city n. For every city, we are just seeing if the number of days on which it rains on this city is 0, 1, 2. If it is 0, then just increment the answer by 1, because you know that it will definitely remain dry. If the count is 1, it means that if you avoid this day, then the city can become dry. And if it is 2, then it means that if you avoid both of these days, then it can remain dry. Now you see that the combinations of day, you see that the combinations. Okay, so let's talk about this. This day, you can say that the distinct number of days are definitely equal to n. So this is not anything problematic, but there can be m into m minus 1 by 2 number of combinations, or you can say mc2 number of combinations of two distinct days. So how will you store it? Something like this did come to my mind, and then I realized that for all the for all the elements which are coming in exactly two subsegments, let's say something like this, there will be at most n such pairs, or you can say that you will be incrementing this for at most n cities, so you can have at most n combinations of two distinct cities, day 1 and day 2. Like, sorry, two distinct days. You can have at most n combinations. So it should not be giving you any TLE. Now what you can do is, for all these combinations which you have stored inside a map, you can iterate over them. You can iterate over all the combinations in the map. And for all the combinations, you will have 2 days, day 1 and day 2. You can say that, rains of day 1 will tell you how many cities will remain dry if you uh, avoid rain on day 1, how many cities will remain dry if you avoid rain on day 2, and in the map, you know how many cities will remain dry if you avoid rain on both of these combined. So add that thing as well. Let's call it as well right now. The combination of these 3 days, these three things will tell you how many different cities will be dried, which are not dried initially. Uh, we are not talking about the cities which are already dry. We are talking about the cities which would become dry if we avoid rain on these 3 days. So whatever you get as the maximum, just store it somewhere. Instead of creating a new variable, I just stored it inside the variable cnt. And there is a possibility of something like this, that rain is happening for, on day 1, rain is happening for the cities 1, 2, 3. And on the second day, rain is happening for the cities 4 and 5. They doesn't have any overlap, but this is possibility. So you can just consider the two max elements two max elements in range array, and the two maximum elements, the sum of two maximum elements actually. Sum of two maximum elements in that, and compare it with CNT, whatever you get as the maximum, just store it inside it and add it to your answer. And now you have got the answer that this is the maximum number of days you can at max have dried. Now I know that my explanation is not not completely telling about every intuition or every implementation of how we do it. It is because if you're solving till even, I've left some part that you're expected to know about it yourself. If I cover up everything, then this problem will become very long. So I hope that it is clear. Please tell me yes or no in the chat if you have got some idea of how to do it, how to approach it. And I would highly suggest you, I would highly recommend you to not be very focused on understanding everything which I discussed here. Take these things as hints and try to do the problem on your own, and you will be able to look at my code for reference. So if you're not able to completely do it by your own, then you can watch the video again or look at my code for reference and then try to code it. Okay, so let's look at the code. So first of all, we took all the inputs for all the days. After that, just sorted all the days because in whichever order I have been given for the rain, like the cities on which the rain will happen on every day, it doesn't really matter. What matters is that on which cities the rain will happen on a particular day. Then I declared this vector of integers rains, in which rain I will tell here. Let me define these things for reference. That rains I will tell how many days, sorry, how many cities are there on which rain happens on ith day only. So if you avoid rain on this day, then these cities will become dry. And then we have this map. So in the map, what we have is a pair of integers, let's say day 1, day 2. It tells that if we avoid rain on these 2 days, like how many cities are there on which rain happens only on 2 days, and both these days are day 1 and day 2. Both the days on which rain happens are day 1 and day 2. This answer tells, initially in this answer, I'm just storing out the number of days which are already dry. And in this CNT variable, I was storing, like I was just using as to keep track of how many days will be there on which rain happens on the ith day. Sorry, ith city. And then this variable is useless. I created it for debugging and then forgot to remove it. And this is the implementation part of what I did. Uh, Let me give a brief overview of what I did for finding out all the cities, like for creating both these things, basically constructing these things. What I did was to sort the array, and after sorting the array, let's say I sorted the array and sorted the subsegments. Now every subsegment is being sorted on the basis of the starting. They will have some overlaps, like this is the overlap, this is the overlap, this is the overlap, and so on. It can have like this. I'm having a set start. I will be going for every city one by one. Now let's say when I come to the city one, in the sets starting rain start, like rain start set, at the first element of the range start will tell that when will be the next range starting. So if the next range is starting here, I will just increment my counter, remove it from my range start, and add the deadline of this range into range end, so that I know key is point after coming to this point, I have to decrement the counter. It is something similar to array difference. Something similar to array difference. And just do this part. And for every like at every point, you would know how many days are there on which rain will happen on the ith city. And if CNT is 0, 1, 2, you can just compare this part. And I think that my implementation would look a little weird to you because everyone has different way of writing. So I would suggest you to do it yourself. But this is a hint of what I did here. And after that, I just found the two largest elements in this range array. And after that, I just stored the maximum of CNT and rain on ith day, like day one, day two, and the common days. Basically, again, something you can do yourself. At the end, just found the answer. So, implement for the implementation purpose, I would highly recommend you to try it yourself mainly, and take my code only for reference. So, uh, does this make sense? And have you got some idea for the problem or not? Okay, that sounds good. So, I think when that we can end the session for now. And for those who have been watching this on YouTube, if you have been watching till now, then feel free to like the video and subscribe. Thank you and bye bye.